Hello, my name is Robert Kozowski. I'm going to be talking about protective fabrics, and the premier protective fabric is aromatic nylon, more commonly known as Kevlar and Nomex. Those were the first products. Now there's a number of other products that are essentially the same. Anyway, these are inherently flame resistant. They're wonderful fabrics. It has an LOI of 27.5. And interesting though, however, it does burn if you burn it under right conditions, if you burn it from underneath. And also I want to mention, does not expand when ignited. It does not melt, no dripping. And no dripping is important because that's nylon and other regular nylon. It drips and causes severe burns. Now, the only drawback to this material is it's expensive because you have to create fibers from spinning. And the two aromatics, one of them, the meta, is done in a DMAC solution, which means a solvent. You have to recover all the solvent when you're doing it. And the other, the para, is the fumed sulfuric acid, and that's not an easy task to create a fiber from sulfuric acid, and you have to accumulate all the fuming sulfuric acid. Anyway, this is a huge worldwide business. Greater than 1 billion pounds of, or $1 billion of this material has been made. Now let's go over and look at the FR, the aliphatic nylon. That's the kind of regular nylon you know from your toothbrush or camping gear. And we've developed a flame retardant that flame retards the nylon. And it's a candidate for this protective apparel business. PNS compounded into nylon, we can get up to 35% in there, and the LOI is 31 at 20% loading of the PNS, and we're going to demonstrate that today. And it burns differently than the aromatic nylon does. For example, it forms a black foamy char. It's an expanded char, which is important, and it melts only when it's a large mass. But if you have a 10 micron fiber of our material here, it goes directly to a foamed char, and it skips the dripping. Now, what's attractive about this is that this may give you some advantages, who knows, until we make fabrics and do that. Melt spinning is inexpensive and environmentally friendly, etc. And we will also today show a good synergy with cotton yarn and also with PET cotton. So let me get started, as we don't want to make this too long. And let me demonstrate first. This will be just some a mass of the aromatic nylon. And we can see that it really does burn. So to one who's untrained in this, this probably doesn't look too impressive, but actually this is extremely impressive, and people really know how to make this into wonderful fabrics that have a great deal of utility in the marketplace. Now, let me go next to the flame retardant we're going to be using. And this is what we call PNS, for phosphorus nitrogen solution. In the end, we're going to go back to this. And let me show how it behaves, though. In this, we compound into nylon and all kinds of materials, polymers. And it has what we call a foaming char. And we see that it really expands really significantly. And you can imagine putting this into your fiber, you can imagine how this foaming will have great benefit. In fact, let's just push some over, and we see that the foaming protects underneath here. So this would be highly desirable. Certainly we found to be highly desirable in wiring cable for jackets and things like that. And we think it'll be also just as good in fibers. Now, before we go further, let's see how regular nylon burns. And we're going to see that regular nylon, the kind you have in your toothbrush, etc., it's going to drip, and in fact it's hard to get it on fire because it starts dripping, although its actually flammability is actually worse than cotton. And we see we have these flaming drips. It is extremely dangerous in a fabric because if these drips hit your skin, they will cause deep burns, because they do not flick off. Now let's switch to our candidate material. This will be nylon 6/6 loaded with 20% of our flame retardant. And we're actually going to see that it catches on fire, and at first you might think, oh, you're going in the wrong direction. But more importantly, though, the flame retardant actually really suppresses the dripping. And here we're burning, and now we turn it upside down. And what we want to demonstrate is that the fire goes out, and you see this wonderful intumescent foaming there that is a little bit thicker than what you started with. And this is what, if you had 10 microns, it's going to go completely do away with the melting behavior. And that's what you want to do in a fabric. And remember that the inherent flammability of this material here is actually superior to that of the aromatic at this point. Now, the next on my here is to actually now show you the fabrics. Treated fabrics. Now, this is just regular cotton, and to show you how this burns. It's just garden variety cotton, and we see that it burns really quite readily. But the important thing about this, it doesn't melt. So if it gets on your skin or near your body, you can flick it off, and it doesn't embed. And so, anyway, we see here that after a couple of seconds here, it's done for. In fact, it seems to get it out. Now let's go to we took the same fabric and we treated it with one of our many variations of this invention. This PNS is a aqueous form, and we're going to see what if it burns. It's a very relatively small amount down there, and in real life, you have to pass a vertical burn test with a burner about this size. In 12 seconds, you can't burn more than 4 inches. So we see we have no burning behavior whatsoever, and this is for coated cotton. Now, let's go to a coated polyester cotton blend, which of course is very common. And we see that also does not burn. And we have this on here, the flame on here, for around 12 seconds. And we would, if it burned for 4 inches, we would still pass. But it doesn't burn at all. So at this point, why don't we just give it a little more aggressive test, and that is to see what happens if we hit it with a actual flame, a really good sized torch. So this is about 12 seconds, and we see that we have the intumescent charring protecting the fabric, and we've gone 12 seconds with a 3500 degree temperature torch, which is what this kind of torch is, and we have no burning. And let's go back to our cotton fabric. And again, we're hitting with 3,500 degrees, and this cotton fabric is not disappearing before our eyes as the one would normally expect. So anyway, this material has extraordinary benefit in creating things that do not burn. Now let me go to my last slide. I'm trying to keep this under 7 minutes. In this we want to describe our invention here. PNS stands for phosphorus nitrogen solution. Now this is really important that our stability exceeds 350 degrees centigrade, because you want your temperature of your material to exceed, or to be somewhat just below the decomposition of your material you're flame retarding. It is an extremely high phosphorus nitrogen content of 27 and 14. It's self-intumescent, as we've seen. It does not require carbonific or blowing agent. Applicable to all polymers, including olefins. Melts into the polymers so that you have less disruption of mechanical properties. And this property enables high loadings. It also should mention that it's applicable to engineering polymers, ABS, SBS, EPDM, TPU, Hytrel. We've tried them all, and they work really well. And I forgot to make one more last, this is the nylon that we were burning, and just want to show you that it still retains the properties of nylon. So you can see it's very flexible, it's still tough, and that because we've put in a 20% loading, it hasn't killed it. It still does act and behave like nylon. Thank you very much.